my web of.
So hi, this is the demo of our application. So we'll be quickly going over through the backend and the front end of our application. So currently on the screen, you can see this is a Google Cloud platform, and this is where the backend and the front end of our application has been deployed. You can see 6 tabs in the screen. I'll be quickly going over through what these tabs do. So let's quickly look over the 5th tab, that is the instance 2 tab. This is the tab in which our backend or the server end is deployed. Our server end is based on Django framework, and that is deployed in instance 2, and all the REST APIs are being catered through here. Then we have the video streaming UI, in which our Angular JS based front end is deployed. Both these servers are US Central 1 zones in order to avoid any latency and to keep the server as near to the user as possible. The other 4 tabs are the Kubernetes pods that we spoke about in our presentation. So these are the pods that are doing the computation of transcoding the video and then saving it inside the server. So these pods have a life cycle of 1 hour. So what happens is whensoever the user uploads a video, the video is made available directly to the user and to the public in the same format in which the user uploaded it. And what happens side by side is in these pods the video is transcoded into different formats and different resolutions. So whenever the video is successfully transcoded, or the time frame of 1 hour is expired, the pod that has being generated particularly for the video that was being uploaded would destroy, and a new request would generate in order to either complete the request, or if the request was completed, to save the video. So the video is being saved into an Amazon S3 bucket. Let's quickly have a look at that bucket as well. So this is the bucket that we are talking about, and in this bucket these are the folders, and each of these folders are the videos. So every video that is uploaded is given ID, and that is ID is associated with that video. In this folder we have 2 main folders. One is a video folder, in which the original format and the original video in fact is being stored, and one is the encoding, wherein the videos that are being encoded by the Kubernetes pods are being stored. So you can see in this one we have 1, 2, 3, 4 and 5. These are the number of resolutions available, and then we have MP4, OGV, WebM. These are the 3 qualities that we have for video formats that we have, because HTML5 supports only these 2 formats, that too on a Chrome browser. If we are trying to operate the website in the Safari or internet browser, it basically would support only MP4. All this validation is being performed. The browser check is being performed in the front end, and the the browser information is being sent to the backend, and accordingly the format is being generated. Now let's quickly have a look on the front end. So I'll just reload the website. So as this is the first time we'll be reloading the website, so no session would have been created, hence this is a fresh start. So as soon as we hit enter, it would try to do all the computation, and it has given us the login page. So before logging in, let me because I have an account already created, let me sign up here in order to show you the encryption type. So let me quickly give in my first name over here, then my last name over here. I'll provide a different username. Let me say and I'll provide my email ID. Quickly provide a password. And let me just show you how things would be working. So let me just clear it. Yes, so I'll try to submit it, and this is the API that we are interested in. According to the API, we have got a result, and in this result we can see that the password that we have is encrypted, and the password that the user sent is being hash coded, and even in the network layer of the client side, the password, the post represents the encrypted password in order to avoid any attacks. Also, you can see the screen size has changed. So when the screen size has changed, this shows that the website is responsive enough. So let me just quickly log back into my account. And I'll give in the password. Yes. So now I've successfully logged in. So now we'll be redirected to our home page. So this is Angular based website. This is a single page web app in which we are using Angular based routing in order to traverse between different pages. This is the main page, and in this one, this is the topmost trending video that we have. You can see we have the file name on the top, and then we have the total number of views. I'll explain over the data base and how where the views are being calculated as well after this demo. So these are all the categories that we have. Again, once I'll complete this front UI demo, we'll be switching over to our SQL database demo, in which we'll be seeing all these categories. So in this one, first of all, I showed you the login page, then the register page, and then we can manually select the transcoding. So these are the different formats that we have available for the videos. In this one, we can see, let's select let's say 360 by 480. It will give me a toast that I have selected it, and as soon as I click agree, the website, the route will reload itself in order to provide a view. So as on the trending video, you can see itself, the video quality just depreciated to 360 to 480, the one that we selected. Let's quickly play any random video. Let's say let's play this one. So another feature that so as you can see, the video quality is quite poor, and what I'll do is I'll go back and I'll select a different video quality in order to give you a better view. So I'll go back and let's say I'll select a slightly better quality. Let's go with this one, and I'll do a reload for the page, and the time that it is being taken. So now we have a fresh video of the requested quality, and let's quickly try to find that video that we played real quick in order to check. Yeah, this was the one. So yeah, we'll play this one again. So yes, so you see the video quality is now quite good as compared to the other one. We'll go back to the home page and we'll quickly have a look on another quick feature. So we'll come back. And you saw that the video just played from where we left, so we are doing the calculation for the the video playback in order to give a more personalized experience. So once you leave the video at a specific time, it will automatically play back from that time. Also, I'll give you another version quality. So this is the topmost quality that we have, and let's quickly try to play a video in here. Okay, so let's play this video. So now I'm recording this via a mic, so the audio for this video would not be available. But what I want to show you real quick is the streaming speed that we have. So this is a fairly big video, and was played before, and you can see it is being streamed. Yeah, so as soon as we receive other packets, a successful streaming is being done. And the streaming speed depends upon the speed of your Wi-Fi. So the video quality is changeable. So you have some basic controls on screen to mute the video and to do full screen mode. Yes, so I'll try to play this video in some other format. So also you have the option to select the format of the video. So as in till now we were playing MP4. Let's try with WebM this time. So selected by format is of WebM. So the next video I'll try to play would be of WebM format. Let's quickly try if that works for us. Let me try with this video. So now whenever I select a format, it will start playing. So I had this user played already, so I have a couple of options to replay those video and to play the next video. We have a tab of view over here and some other tabs as well. The other tabs represent a shortcut to the categories, whereas the U tab is the one in which we'll be providing the option to upload the video. So I'll quickly navigate back to the U tab. Yeah, so so this is the place where you can upload the video. So as soon as you upload a video from here, a Kubernetes pod, which is a pod similar to this one, would be instantiated for that particular video and would be doing all the transcoding. So yeah, and then you have a personalized user detail page in where you can check on your information that you have filled in, your username, and you can update your password as well. And then we have a search bar and some other videos. So yeah, that's basically most of the demo that we have. So we try to create it like on the theme of Netflix, and this is the final product. Let me quickly give you a demo of the database. So this is the schema we have in the database. These are the tables that we tried to normalize and do the encoding in here. We have a video detail table that is one of the primary tables. Let's quickly go to the contents of this table to understand how the APIs are working. So we have this ID column and a video ID column, video name column, video description column, thumbnail URL column, video duration column, which is represents the total duration, video category, which divides segregates the videos according to the categories. Then we have the resolution of the videos in which they were uploaded. Then we have the video encoding as in when they were uploaded, the video part as in the part that I already showed you inside the storage, and some other video size and video count, which is being used to calculate the trending. So we have a video with 85 that I showed you, that was a trending video. Then we have a user credential. Now taking note on this table, we have the ID, the first name, last name, which we are storing. We are storing the password in here, and then you see the password we are storing in here is also encrypted, and it is being decrypted at the time of the request being served. Then we have the video transaction table, and this is the main transaction table that we are using for a personalized video playback. We have a video ID, an ID, a video ID, the duration as in when the last duration the specified user left that code in, and a user ID. So yeah, this is pretty much our database.